Stage 2 is the decode stage. The responsibility of the decode stage is to determine what registers we need to read from the register file and then actually read those values. So clearly, we're going to need the RA and RB fields from the instruction, and we'll need the register file. But we're also going to need some logic to determine which registers are going to be used to produce the values that come out of the register file. Let's look at this from picture form. Normally, we'll just take RA and RB and pass it into some logic that will then tell the register file which registers to read. We'll read those registers, and we're going to produce values that we're going to call val A and val B. And you'll see throughout the rest of this talk that we're going to name some of the signals and inputs and outputs to these blocks. But maybe it's not always that simple. Let's look at some of the instructions that we have to deal with. No op and halt, not very interesting. Move instructions. Typically, those end up using some combination of RA and RB, so maybe that's okay. ALU instructions use RA and RB. Jump instructions don't tend to really use either. But what about push and pop and call and return? Rather than specifying the registers that we need, push, pop, call, and return have an implied register, which is the stack pointer. RSP is still in the register file, and sometimes we're going to need that, and we're going to want to read it out into one of the values. So in addition to sending RA and RB into these little logic blocks, we're also going to have to send the I code, right? What opcode are we doing? Because sometimes that will imply that we're going to need RSP instead of whatever value is in RA or RB. So we started out by saying that the decode stage needed RA and RB, but in fact, it also is going to need the I code.